Hello everybody. Today we are going to be talking about defining typology of interactivity, a little bit about interactivity and visualization. In that order of ideas, our learning objectives for today is to compare techniques of interaction with population health data. And this is a really interesting topic, and it's based on in the theory of interaction. And when we are thinking about visual representations and visualization in general, we can go to the introduction of this book that is called Visual Explanation, Images and Quantities, Evidence and Narrative by Tofte. And he said in the introduction that assessment of change, dynamics, and cause and effect are the heart of thinking and explanation. To understand is to know what cause provokes what effect, what by what means, and at what rate, then how there is such knowledge to be represented. And if you see this in this question, if we want to see how things are changing, moving, if there are cause effect, this is healthcare. If we want to understand the causes, if we want to understand the means, if we want to understand the speed, then definitely we need to be thinking in how we make that knowledge represented, and the answer is the best representation is going to be visual explanation or visual representation or visualization. And that's what we have in the class, no? And then we can go from there, and since we are going to be talking about interaction, then this is a particular topic that enhances the experience of the visualization. Because one thing is to represent something visually, but the other thing is to be able to interact with that representation. And then if we are talking about interaction, and we go to the Oxford dictionary, and it says that interact is to have an effect upon each other. You see, there is a double way of effect. And in the case of a visualization, then we have an observer that has an effect on the visualization, but the visualization is going to have an effect in the observer. And we think in this order of ideas. Even a static map and a static chart could be considered interactive, because you have some kind of interchange of data there. But sometimes you cannot modify that paper or static representation. But of course, when we have complex displays, then we are going to have more interaction, more knowledge. We are going to be able to extract more data out of those complexities. And if we are thinking about interactivity, we can think about, hey, what is general interactivity and what is the interactive technology? And this is something that Cartwright was proposing in 2001. And there is a big difference, because what is interactive in computer technology is not the technology itself. What is interactive in a computer technology is the interface. And for those that you have taken the class of system design, basically it's a class in interface design. And the interface is what? Is all those tools that we have to create inputs and outputs with the system. Then the interface, for example, for a desktop is going to be the keyboard, the mouse, the screen, and we also have the microphone, we have the camera, we have the headphones. All these elements are part of the interface that allow us to interact with the active system. And when we are talking about visualization, and we need to take the interface design concept into account. And we are going to find that there are special requirements when we are talking about spatial visualization, that when we are not using spatial visualization. And at the end, we are going to be contrasting those ideas. And then if we are thinking what type of task people engage when they do visualization, and I put their geovisualization, is because these apply for both visualization in general and geovisualization. Then we have different levels, and they are going to be increasing in complexity. And the first complexity, the first level that we have is to examine. Basically, we look into the data and we have some basic conclusions. We have a threshold to compare. We have a tendency to see. We have some description of the data. But we can compare. We can compare data streams. We can compare points of observation. We can compare populations. We can compare variables. We can start using visualization to compare the behavior of data sets. Then that's the second level of task that we can produce. There is a third order of task, and is to order and to sort, or to reorder and to resort, because these are tasks that we can repeat and redo. Just changing the order of the data, or sorting the data in different ways, we can make some insights of that data more visible or highlight them. And that's something that Tofte is really good on. And if you go into the additional materials, I posted you the link for the PDF of this interesting book. It's not mandatory, but it's really interesting, and how just reordering, how we have a representation effect, and how just the order or how you sort your data and how you present the data is going to have complete different meaning. Then we have another type of task that is to extract or suppress, basically similar to filtering. Then we have subsets, so we remove the outliers, we remove the noise, we remove the confounding variables, and then that's another type of task that we can do with visualization. And last but not least, we can start having some conclusions, some inference or approaches to the cause effect of observations, because you can have a phenomenon and you can identify other type of external events, and maybe you can see changes in the behavior of the data, and then you can attribute some relationship of cause effect there, or at least some correlation that we can start exploring much more. And these are kind of the different tasks in the higher level that we can engage when we are using visualization. Then we can examine the data, we can compare data, we can reorder, sort to change the representation, we can extract or suppress, basically to focus into a particular data, and then we can associate in some way to try to explain cause and effect relationships. And that's the higher level of interaction that we can have. And also, when we are thinking about visualization, there are so many types of resources that we can use, and different media that we can be using. Then when we talk about visualization, we can talk about images, or we can talk about maps, or we can talk about diagrams, graphs, tables. And we introduced this in the previous class about different dimensions and different concepts on visualization. And these resources, these different ways of resources, they are going to have different functions. They can have a static representation of a phenomenon, but they can be animated. Then we can have different screenshots, different snapshots that are presented one after that, and we have that illusion of movement of animation. We can have sequentially represented images, maps, diagrams, graphs, and tables, or we can hierarchies on them, and the hierarchies are basically based on some filters or some data. We can create a drilling or a specific looking into that, or we can have conditional functions where we present some of the data depending on some constraints that we are proposing in there. Then as you see, interaction starts from a really basic presentation that is the static, and we can have a minimal interaction there, but we can interact in animation, we can interact in creating sequences, we can interact in creating hierarchy on the data, or we can create interaction by creating conditions or filtering or restrictions. Then as I said, the static function cannot really consider to be truly interactive, but as the theory says, even a static image, if you have spent so much time or it is complex enough, you are going to have some kind of interaction. Animation is that change of motion, and the sequential and hierarchy describes that basically we are having real interaction. And then in this typology of the interactivity of the interaction, we are going to have different levels that we can interact with. And the first level is going to be the data representation. We can interact in the way that the data is represented or presented. And some of the elements that we are going to have in data representation are called lighting, viewpoint, orientation, zoom in, zoom out, rescaling, and remapping symbols. And we are going to look at them into the detail further in this talk. The second level of interactivity is when we interact with the temporal dimension. And in that regards, we can have experience like navigation, we can have fly-throughs, we can toggle from before and after, and we can have the sorting or re-expression or reorganization of data. In the third level, then we are not interacting with the visualization per se, but we can interact with the data itself. And in that regards, we can have querying, data mining, we can use brushing in the statistical level, temporal or spatial level. We can do filtering, like excluding, they presented you in the hierarchy of the functions. We can have highlighting by including by some criteria, so creating some conditions. And in the fourth level of interactivity, then we have the contextualizing interaction. And that contextualizing interaction is related with having multiple views of the data or multiple views of sources. We can combine different data layers. We can have juxtaposition of windows. We can link data. What is important to know about this typology of interactivity is that when we interact with the data representation, then we consider that is a low level of interaction. When we interact with the temporal dimension, we can say that we have a middle level of interaction. But when we interact directly with the data or with the context, then we are going to be talking of high levels of interaction. Then let's go on deep into the concepts that we are presenting and talk about data representation, temporal dimensions, data, and contextualization interaction. The interaction with data representation, as we say, is basically the use of different views, perspectives, representation, and the way that we are manipulating the way that they look, how we perceive them. And they are less interactive, as I said, but they are correlated with the first level of interaction that we presented in the pyramid, that is basically helping us to examine the data, how we examine the data. And let's go a little bit further. And what is lighting then, for example? Then lighting is the effect of an scene that is telling us that that lighting is this effect that you can create in a scene to influence the interpretation or to influence the pattern recognition. Then lighting could be something like just highlighting or illuminating a portion of a representation. We can use some kind of colors, we can have some kind of shadowing, or we can basically use the contrast to magnify something that we want the user to look into that. Now, what is changing the view or the viewpoint of the camera? Then this is a metaphor that is used in visualization, and since we are the viewer, then we can have an artificial camera or a virtual camera that is looking into the data or is looking into the representation. And what is talking about this is once you change the position of the camera or the point of view, then you are going to have a different conclusion, and you can see the data in different ways. An example of changing the viewpoint is you change contrast in the data, or you change the divisions or the boxes or the segments or the categories that you are aggregating the data. When you have continued data and you create some chunks of data, then you can remove those barriers or create artificial ones, and then you change the viewpoint of the way that you present the data and or the position that the user is looking into the data, and it's going to change completely the representation. We can change also the orientation, and this is an extension of that model of the camera, and is to create new perspectives about the data. And for example, in the maps, scrolling through maps, you are going to be looking into the different elements or perspectives, or you can see different data, and we are going to present examples of this later. If I do zoom in, zoom out, is basically how we scale into the data or into the visualization, because sometimes when you have a scale that has huge ranges, you cannot perceive differences, and maybe those differences are going to be significant. Then you can change the range of reference and then doing zoom in, zoom out, and is going to change the perspective or in understanding of the data. Or when you are in a map, for example, or in a geographical representation, you can have different details and different type of aggregate information depending of that level of specificity or that level that you are looking. And in this regards, we can talk about the macro or the macro or the micro viewpoint of the data. You can look really into detail, or you can have the big pictures. And here we are just talking about that, the scale. What is the scale? What is the reference that we are using, and how we are filtering that data in order to better understand or make things visible for the users. And rescaling then is related with that zoom in, zoom out, but we can change the scale from linear to logarithmic or different other representation that just changes or magnify the differences between groups. Then this is a really interesting possibility of the interaction, because sometimes you don't see change, but you change the scale and now it's visible, and now you can interpret the thing in a different way. Then in rescaling, an example in maps is the racial category by total of number of people and create racial densities instead of having row counts. Okay, then you are just changing a variable and the reference then to create a new scale. And this helps you in the sense that you have different people living in the different representation or geographical areas, but if you create a density, then it's basically a ratio. You are changing the scale. Now you are not using counts, but you're using a normalization of data. You are accounting for those fluctuations. And this is really, really important, for example, in some representation that we are going to be exploring as the choropleth mapping, because the shading, the intensity of the color is going to be usually directly proportional to the density of the data. We also can have different symbols. Remember that we are talking about mapping in the previous class. Sometimes just changing the symbol itself or changing the color is going to help us to create that contrast, create that representation. But we need to be aware that there are certain colors that they are not displayed well in certain representation or certain interfaces, and then having the probability of changing colors or changing the symbols is also a tool to facilitate people to understand the data and the visualization. We can change, for example, squares to circles, color maps, color ramps, or different type of color schemas. Now, the second level that we introduce is the concept of the interaction with temporal dimension. And when we interact with temporal dimension, then basically we are creating movement in some way. No? We can have interactions like a dynamic mapping. Those are displays that can change continuously with or without the user input. And then we can have dynamic changes of data through time. We can have also an animated map. This is a type of dynamic map, but we can stop and we can continue. Basically, we add that layer of control into the mapping. And a fly through is one special conditions where we can control the route or the speed or the altitude or any of these references on space time. And we can control the space position, and then it's related with the camera point of view, or we can control the temporal dimension and just ubicate ourselves in different point of view of the data. Flybys or fly-throughs, these are basically animated journeys through a terrain, and they can be consecutive views of that terrain. Or it's just a set of frames that if we present them between 15 and 24 frames per second, we are going to have that illusion of movement. If you are familiar with cinema, if you are familiar with these animated visual effects, these are the rates that our eye is able to perceive movement. Sometimes we need more rate, but we are going to be seeing that, for example, we are in this race for refresh rates in screens, and now we are talking 120 hertz in the screen. Yes, those are 120 frames per second in a screen. It gives the appearance of being more smoother, but there is a limit in our eye that we don't see the difference anymore. What happens is when you increase the frequency, the chances of having a flickering reduces, because when you have a low frame rate, our shutter speed or can be synchronized with some of the black frames, then we can have that experience of flickering in our brain. But if you have more frames, you are reducing the time of exposition and the possibility of having that effect of flickering. But we don't necessarily need to have that much frame rate to really have experience. With 15 to 20 frames per second is more than enough. Usually they are not highly interactive unless we really can control dimensions of space or dimensions of time. And usually that route is going to be not manipulable in the flybys. In the fly through, then the viewer is the one that can choose their own route through the terrain or the data and be able to find some decisions. And these modes of navigation, they are not available usually in the physical world, but we can float, we can go through objects, we can dig into underground. There are a lot of interesting things that we can do in 3D virtual spaces when we are dealing with data. And I think you have seen movies like Minority Report or other type of these movies of sci-fi science fiction where they have really interesting visualization that you can manipulate the data and go through the data in virtual environments. Now, toggling is, as I said, switching between two time of periods or before and after, things like that. Then when you are toggling, then in a visualization you can see the contracts quickly and see where the changes exist. Sorting is to be able to change the data a long time, or sorting the events in a different dimensions that are going to help you to visualize things. Then, for example, if you have a data that is presented alphabetically but you reorder them chronological, maybe you are going to see something different, no? And it's going to present you different conclusions. Or interaction. Now the third level is the interaction with data, and as we said, this is not just interacting with the visualization, but actually you are manipulating the data that you're using, and the interactivity is high. In this order of ideas, you can identify, discover, and select pertinent patterns that you have in the data, and then is the one that you use to visualize. And then the querying and data mining, you are going to have a time dedicated for querying data in your EPIC 700. And when you are doing querying and data mining, you can discover hidden patterns, tendency in the data, and that's an interactive discovery when you are using this type of tools to try to find relationships, patterns, and generate hypotheses. No? And that's the power of data mining. When you are doing brushing, it's a really long-standing type of interactivity, and basically the brushing could be statistical or temporal, and the idea is to explore correlations between some statistical and some geographical patterns, and then you use visualization to try to match those things. And there are three types of brushes. You have the spatial brush, you have the statistical brush, and you have the temporal brush. Then, as you can see, we have the 3 dimensions of the space, we have the time, and we have the data, and they are linked in some way, and then you can use them trying to paint or brush over one of these dimensions and see what is happening. Filtering then is a process where some data is excluded, and that simplifies your display and visualization, because you can just remove what is extraneous and what's making noise. The highlighting is opposite to filtering, because you keep the data but you emphasize certain type of data. within the whole context. And now that gives introduction to the contextualization interaction, that the context basically is all what surrounds the analysis, and this is going to really inform the way that we interpret the data. And this is something that we discuss in human-computer interactions and in the same class, because remember that we create information based in our previous knowledge. And if I don't have the right context, then I can have wrong conclusions. And that's why creating the right context and providing the right context, or highlighting that context is really important, because different contexts are going to create different conclusions, even if you are using the same data visualization tools. And we need to be clear on that. An example is we write left to right, but there are languages that are written right to left, and the concept of future and the concept of flow could be different. Then sometimes the future is seen in the left when we tend to see the future on the right. But it's just created by the way that we have our context and our knowledge and our culture that influence that interpretation. Then we need to be aware of those things. We also have these tools of multiple views, and take the same data and be able to present that in different representations, in complete different structures. And maybe we can present data in a map, we can present data in a chart, we can present data in animation. Different multiple views can help with that context, with that extraction of information. And we also have small multiples. This is another sophistication in order to create comparisons. But then you have basically different sets of data display more than once in different spaces. Then you can compare those buckets in different level. And you are maybe familiar with these small multiples when you were looking into maps of COVID, and you see the deaths, you have the hospitalization, you have the vaccination. Those are the small multiples of the data that basically in that case was the same map, but the map was having different densities, and the densities were telling you different stories. Then that was basically we're comparing the geographic location and be able to identify what we used to call the hotspots, because then we have this dimensional data in this multiple representation, and then we can have conclusions just by the way that we were presenting that. The linked maps is when you have one or two or more data sets, and they are linked dynamically in a map, and then we can have these dimensions represented in different ways. Data layers, this is something common like in Google Maps, where you can have geographic information for location of something, but you can have additionally food access, or you can have health conditions, you can have vaccination, and then you can create different layers on a map, and that helps you to create interesting visualization. The window juxtaposition is that creation of different perspectives of data. Then it's when you have an animation versus a overhead view, or two windows showing cross sections of different depths on time, or having a 3D space representing from different dimensions. Then that helps you to understand the data from different point of view. Is similar to the changing the camera, but you are doing this simultaneously in different dimensions. And linking is this technique that connects indexes from one data set with another, and different to brushing, linking is not doesn't need to be dynamic. Okay, the linking could be in some way static, and usually is more inclusive than brushing. Then if we want to bring this concept of interaction into just spatial data is when we introduce the concept of geographical visualization. And geographical visualization is the use of concrete visual representations. It could be in paper, it could be in a computer display, it could be any other medium. We have that spatial context and we make a problem visible in such way that humans can engage with that problem. And we are just exploring that capability of we are visual subjects. Then usually geographic visualization are highly interactive, highly exploratory. And as you see, this is not new. These concepts are from the 90s. And when we talk about geovisualization, then it's a term that integrates the approaches from visualization in scientific computer, cartography, image analysis, information visualization, exploratory data analysis, geographic information systems, and is creating a theory methods in order to create exploration, analysis, synthesis, and presentation of that geospatial data. And what is geospatial data? Basically data that we can put in a map. And we have the coordinates, or we have a zip code, or we have a city, or we have a state, something that we can anchor to a spatial location or a geographical location and make conclusions. And as you see, location is really important in population, because population is that group of people that share a common characteristic, and sometimes population, the characteristic is the physical space that they share. These arose from efforts in the early 80s in order to visualize the large volumes of data, and this is a scientific field that has been extended to really be applied for solving human problems. And as you see, maybe this class, that is dashboard, is going to have a huge tendency towards geovisualization. Even though we are going to be explaining general approaches, we are going to be heavily inclined to geographical representation. The context in geovisualizations then allow us to create thresholds, correlations between variables. We can go from low correlations and depending on the dynamic variations and change the context, then we can start looking things that are more evident or things that are less important. Then that kind of interaction can help us to make visible the invisible, or vice versa. The traditional static maps are not interactive, and then the most important thing about visualization is that we can have inputs, and those inputs are going to have changes in the visualization, changes in the display, and that's a requirement that we have input in order to change the representation. Then in geospatial representation, we can have statistics, and remember that these are some of those elements that we have in interactions, and we can dynamically allocate data according to some threshold, no? Or we can sort individual data into particular bins or buckets or segments, and then they are going to be represented differently. This is analog to sorting the mail in post office. Then you have different destinations, and then you can have different slots or bins, and then let's say we can do this by a block, we can do this by a neighborhood, we can do this by zip code, we can do this by city. Those are the different buckets that we can have there, and that's going to change the context and the dynamic of the data. We can also do visual thinking, and at the end the goal of geovisualization is not to create an ideal map, but to provide a way that we can explore data and generate ideas about the phenomenon that we are representing. Yes, there are not perfect solutions, but just these are tools to make visible the invisible, as I was saying before. We need to have that interactivity. That's a condition definitely in geovisualization, because that's what is going to distinguish us from a traditional or static map, and is fundamental component. And that's going to increase the enjoyment of the map. And of course, if we want to have interactive maps, we need to have some kind of electronic system. Then, because paper is really difficult to create these active interactive systems, even though we can achieve some level of interaction, it's not really at that level. And then the extensions that we have from interactive from paper are essential to have an interactive map use. Then interactive definitely is used while in geographical visualization, and it helps to have an intuitive appeal, and then people can manipulate things and be there in order to extend the emphasis of the geovisualization in that function to explore, be interactive, and create that spatial analysis. Then, as we have said, then interactivity is just that capability that we have to change the display to that user input. But what is really important is that answer of the system needs to be really short interval. It has to be less than 1 second. An interactive system that is taking more than 10 seconds to respond is going to be perceived by the user as useless. But if we really want to be in the domain of interactivity and we are acting, then we need to have rapid response. And then we have new challenges here, and it's how we access the data, how we pre-process the data to make that available, that when there is a change in the interaction input, we can update that quickly. And we need to take into account that that input can be from a single or multiple users at the same time. Then we need to account for that when we are designing the systems. Then, as we said, some interactivity are more strong than other, and we are already presenting different type of those interactivities. We can have restricted interactivity in geovisualization, that is basically viewing, browsing, and selecting some map areas, some level of zoom, or scrolling around the map. This is the basic level of interactivity, or restricted or low interactivity, and it's in the domain of the representation, that we are interacting with the representation. But we can have complex levels of interactivity when we have the interaction with the data, and we can interact with the graphic content or the structure of the system, and we can access different levels of representation of data. Highly interactive geovisualization systems are defined not only for those systems that incorporates more kinds of interactivity, but those that combine different types of interactivity. Okay? And the key is the combination, no is to have them isolated, but to be able to combine the interaction is what's going to create that higher interactivity and be able to create sophisticated queries or inquiries to the system. Then at least we expect to have more complex uses identifying literature search, context interactivity, or broaching. Those are the first things that we want to have. And the highest level of interactivity is when we have analytical capabilities in the representation. And it's when the user is truly involved not only in the evaluation of the data, but in the visualization of that geographical information, and we are transforming that. And then in this case, we include manipulation, management, analysis, linking data, and graphically redesigning. That's the highest level of interactivity. And in this content, then definitely we want to have an interactive environment and be able to have one or more type of interactions in the different levels that we already discussed previously. There are issues with interaction in spatial data. There are cognitive issues because people can have problems in navigation, how to navigate. They are not familiar with the spatial representation. They cannot be able to go to the destination, or they can get disoriented. And then we need to take that into account. And also we have challenges in how to modify objects that are not available in two-dimensional maps. How I pick an object, how I rotate them. Because right now the haptic technology is limited, and then we need to have other representation and other manipulation and other ways to help the people to interact with the data. But those are one of those usability challenges that we are facing nowadays in interactivity in healthcare. It's important to take into account this concept of the Monmonier's graphic scripts. Then it's about a story, and we are going to be talking about storytelling and how to create these scripts in order to have a way that you start the user, introduce the user to your visualization, and how could be a navigation tool or a guide until they come to an end. Then those scripts talk about how that interactively is structured, and in how to use that in a particular situation. And basically is that narrative, is what are going to be the elements that we need to have that. And that's why we are going to be talking about storytelling in future classes, since it's a really important element, and it's the ultimate goal that we want to have with visualization, to be able to convey some information to transmit that. Then when we review the literature, why do we need to know about this typology? Then and it's important to understand that geographical visualization is completely different to a traditional and static mapping, because we have more levels of interactivity, and it allows to identify differences between computer mapping systems. And this typology of interactivity gives interface designers a way to measure the effectiveness, no? And then it's going to help us to position, okay, then when we have this tool, now you have elements to be able to say, I am examining, or I'm able to compare, or I can sort. Can I infer cause and effects? Then are those dimensions. Or I'm working in a static system, or I'm able to do some more complex. I'm using imagery, I'm using mapping, what I'm using, how I'm located, and then you can see that there are different levels of that. Having conditional interactivity is important because that helps in the decision making process, and how the user choose what to see and what to learn, and to create those explorations. Some benefits of having a typology of interactivity is that if you are aware of that, we can create more powerful visualization tools. We can compare and critique different mappings and different visualizations. Be able to say, hey, this is better than that other one, not because it's prettier, but because the functionality that is providing is superior, and I can do more operations, or I can manipulate the data in some other ways. And last but not least, as I mentioned before, this gives a mechanism to identify needs and how to measure that interface effectiveness. Then I hope that I have conveyed with you this concept of interactivity, that interactivity has different levels. I have used the geographic visualization as an example of how this can evolve and be in those different levels. And I hope to see you in the interactive session that we are going to have some practical examples, and we are going to be open to the discussions. We are going to be recording that session. Thank you for your attention, and see you in the interactive session or in the recording of that session.